Okay, I wanted to walk you through number 3 on this homework assignment because I feel like it's pretty difficult, um, mainly because of that argument there that's 5 minus x. Okay, so don't worry about that quite yet. Start by just asking ourselves, okay, what x values do we want for our graph? Well, we always want the argument, so what's in the parentheses there, to equal 1 and the base of our particular logarithm. So in this case, the base is 3. So the two equations we're going to set up, we're going to take the argument, 5 minus x, and make it equal 1 and make it equal 3. Okay. So when we want that to equal 1, whoops, sorry, that got a little sloppy there on me. Let's just move that out of the way. We subtract 5 on both sides, leaves me negative x is equal to negative 4. Divide both sides by negative 1, you get a value of 4. When we set it equal to 3, we subtract 5 on both sides, get negative x equals negative 2. Divide both sides by negative 1, our x value is 2. So our chosen x values are 2 and 4. So now it comes time, we need to substitute, plug each one of those into our equation and see what y would equal. Okay. So when I want to go put 2 in, it would look something like this. So f of 2, we would say we're doing log base 3 of 5. Now it's minus 2. Well, that turns into log base 3 of 3. Now, hopefully these are becoming more automatic to you, but if not quite there yet, you convert this into exponential form or exponent form and say, okay, this is 3 to some power has to equal 3. Well, the only way for that to happen is if the exponent, if the question mark there is replaced with a 1. 3 to the first would be 3. And very similarly, when we substitute 4, come on, click, why don't you? When we substitute 4 into the formula, we get log base 3 of 5 minus 4, which gives us 1 as our argument. Well, when we convert that into exponent form, 3 to some power then is supposed to equal 1. Well, the only way to make that happen is if the exponent is 0. Right, so we sub in 2, we get a y value of 1. When we sub in 4, our y value is 0. Okay, so there's our 2 points. Okay, now before I even throw those onto the graph and possibly mislead or confuse myself, the one other important aspect of the graph we have to identify is the asymptote. And that is where this one kind of is tricky, right? Because our asymptote comes from our transformations. And if I look inside the argument here, if I look at 5 minus x, it just feels off, right? It feels backwards, okay? And it sort of is. So our first step, what we want to do with that, and I'm going to come down here and demonstrate it when I'm thinking about transformations, I want that to be in the other order. I want the x term first. So we're going to rewrite the argument as negative x plus 5. And it's okay to do that because we haven't changed the sign of anything. That 5 is still positive and this x is still negative. They're just reversed. Okay. Well, how is that helpful? Well, we still want it to say x plus or x minus some value. But right now it's negative x. So what we have to do, and we got to reach back into our brains to Algebra 1 when we were doing factoring, we need to factor out or undistribute a negative 1 so that it's not right there in front of the x anymore. So when we undistribute negative 1, what that does is it changes the signs. So that negative x turns to positive x, and that positive 5 becomes negative 5. Or you could simply write it as negative sign and then the quantity x minus 5. Well, what does that do for us? That means our logarithm, our equation, now looks like log base 3 of, and this new expression with the negative sign outside the quantity x minus 5, that's our argument. Well, now we can pick apart for transformations that negative sign that is inside the argument makes us reflect over the y-axis, right? Because it's inside. A negative out front would have reflected over the x-axis, but when it's inside here, it goes over the y-axis. And now this looks more what I'm used to, and I could go, oh, it translates right 5 because h is 5. Right? So our transformations, it translates right 5 units and reflects over the y-axis. So if you can picture that, my asymptote will be over here at 5. But when it reflects over the y-axis, it's going to change from an increasing graph to a decreasing graph. Okay? And you're adding the 2 points and the asymptote to our graph. Look about like that. Okay? That's the 2 points from my table, 2, 1, and 4, 0, along with, I now know the asymptote is x equals 5. Sorry, I didn't put that up. X equals 5 due to it translating right 5. And then don't be afraid to draw your curve is actually decreasing. Now, it was those transformations and therefore the asymptote and then in the long run, it's the picture of the graph you drew. Those are the difficult parts. The rest of these, once we have the graph, they kind of fall into place. They're not a big deal. Our domain, leftiest to rightiest, well, this time it goes all the way to the left. It does not go to infinity going to the right because I have the asymptote on that side this time. So our domain will look kind of reverse of what we're used to, but it goes from negative infinity up to almost 5. Won't actually ever reach 5. Range, we have said before, will never change, and I'm not going to break that promise. It is from negative infinity to infinity, bottom to top. Increasing or decreasing. Remember, we'll never have both, but because of the reflection, this one is now decreasing over the whole domain, and it has no increasing interval. Okay. Now, there's one more we can do just from our picture. We'll have to solve for x and y intercepts, but the end behavior, again, it's going to feel a little funny because of the reflection, but if we think of the left side of this one, the left side this time, x's are going towards negative infinity, and the y values are going up towards infinity. Then on the right-hand side, that's the side that is now approaching the asymptote. So we say as x approaches 5, the y values are headed down towards negative infinity. All right. Now, intercepts. This is the newest thing we learned, but hopefully it's becoming easier. This particular graph will have both. You can see right here, it's crossing the y-axis. But it also, I actually have a point right there on the x-axis. So technically, I already know my x-intercept. It's in the table, 4, 0. Because we're used to setting up and solving that, let me go ahead and show you what that would have looked like for the practice. We always make the opposite variable equal 0, so the y value is 0, equals log base 3, 5 minus x. Turn that into exponent form, it becomes base 3 exponent 0 has to equal the argument 5 minus x, and then solve. And again, you can see why or where we found that x has to be 4. Right? X-intercept definitely 4, 0. Now y-intercept, we haven't had many of those. Usually they didn't work out for us, and we had to say no y-intercept. This time, though, we're going to replace the x with a 0 in our equation. So this becomes log base 3 of 5 minus 0, or just 5. So I think, what would this look like in exponent form? So it means 3 to some power needs to equal 5. Well, I don't know any number. It must be some decimal value or fraction value. So we're not going to try to find that right now. We're just going to say, okay, That's the best y value we can get right here, that y has to equal log base 3 of 5. So our y-intercept then is just x0, y is log base 3 of 5. Okay. All right. I hope that helped. See you at school tomorrow.